dinosaurs were discovered, nobody wanted to believe that. That was really a shocking thought that these giant creatures actually existed way prior to human beings. Things like meteorites. No one believed that meteorites existed. Thomas Jefferson famously said, no such thing as a rock could fall from heaven. That doesn't make any sense at all. But we now know meteorites not only fall from heaven, but they've fallen from the planet Mars and landed on the Earth.
I cannot identify a paradigm-shifting set of ideas more profound, more fundamental, more sweeping in their implications than the electric universe paradigm. But everyone in our group recognizes that there is a wall that is almost impossible to penetrate.
So much money is going into science and lots of progress. The progress is incremental, not many scientific revolutions. We face a lot of problems these days that need solutions, and often solutions will come from scientific revolutions.
I suddenly realized that to get any further, I had to discard Einstein's way of looking at things.
People take the dogmas of science to be a kind of religious belief system or quasi-religious belief system. And it's this dogmatic belief system which I think is now constricting and holding science back in a very serious way.
Science is no different to any other human endeavour. All the base elements that are present in other aspects of society are present in science.
Peer review doesn't work. It only works to protect the status quo, the settled science.
Part of the problem is that the scientists have taught what was taught in 1950 since 1950.
We are today in the midst of a revolution.
A earth-shaking revolution in human thought is coming.
In the 1920s, there lived a scientist named Velikovsky. He was trained in medicine and in Freudian psychiatry. He practiced in Palestine and wrote many scientific papers and articles, even collaborating with Einstein, who became a good friend. When World War II threatened, Velikovsky moved his family to New York and devoted himself to the research of ancient texts, including the Old Testament and ancient Egyptian documents. This led him to form a theory that Earth went through intense catastrophes and cataclysms around 3,500 years ago. He sent his findings to leading academic libraries and scientists.
Velikovsky came across the understanding that the ancient peoples had suffered a terrible catastrophic disaster which was on a global scale. He wanted to find out what the agent was, and it became abundantly clear, and it's been clear to all of the scholars who followed his work, that it was the planet Venus was the archetypal comet. It was the doomsday comet. And it explains all sorts of odd things, like why do people think that these comets that we see today could ever be considered as the bringers of destruction of the Earth.
In 1950, his book Worlds in Collision was published and became an instant New York Times bestseller, but received huge backlash from the mainstream scientific community.
Here's Velikovsky. He's just published a bestseller, and it is rejecting the standard history of the solar system, and it's proposing things that are utterly preposterous if you are holding to the standard view of solar system history. He said, Venus appeared in the ancient sky as a comet. It was an Earth-threatening comet. It was terrifying. It dominated human imagination. And humanity's experience of this comet, Velikovsky said, shows up in human records that we think of as myth.
I mean, the word myth used to mean, a falsehood, and then myth then became something, a sacred story. It kind of got elevated. And now it's become possible to view it as physical history. We've started to change our attitude, and that's the only thing that exists in the human record that could tell us what happened in the past.
Famously, the young Cornell astronomy professor Carl Sagan proceeded to systematically criticize and encourage suppression of the work of Velikovsky.
There is a curious argument alleging major recent collisions in the solar system proposed by a psychiatrist named Immanuel Velikovsky in 1950. He suggested that an object of planetary mass, which he called a comet, was somehow produced in the Jupiter system. He doesn't say exactly how it's produced, but maybe it's spat out of Jupiter.
Eventually, however, some of Velikovsky's work was indeed proven to be true.
Previously, I'd given a talk about all of the surprises in the solar system that they have discovered during the space age. In 1950, the accepted theory was uniformity, that nothing ever happened drastic on the Earth. The solar system had no electromagnetic fields. The solar system was exactly the way it's been for billions of years, and that mythology was pure fiction. Velikovsky came along and said, all of those aren't true. When they started sending up all the space probes, they found that what he said turned out to be true and what they said didn't. And when you send a space probe to somewhere you haven't been before, the results are usually advertised as surprise, astonished, who would have ever expected? We've got to rethink everything. Our theory just doesn't match this.
And Carl Sagan himself backed off somewhat from his earlier harsh criticism.
The worst aspect of the Velikovsky affair is not that many of his ideas were wrong or silly or in gross contradiction to the facts. Rather, the worst aspect is that some scientists attempted to suppress Velikovsky's ideas. The suppression of uncomfortable ideas may be common in religion or in politics, but it is not the path to knowledge, and there's no place for it in the endeavor of science. We do not know beforehand where fundamental insights will arise from about our mysterious and lovely solar system. And the history of our study of the solar system shows clearly that accepted and conventional ideas are often wrong, and that fundamental insights can arise from the most unexpected sources.
Fast forward to David Talbott, a researcher and publisher of comparative mythology.
My name is Dave Talbott, and I have for decades been deeply involved in a new paradigm that is commonly called the electric universe. I am the founder and director of the Thunderbolts project, which has emerged as a very powerful internet voice on behalf of the electric universe. So I, decades ago, was very attracted to the work of Immanuel Velikovsky. In 1972, I began involvement in a project to go public with the Velikovsky debate. That debate was more than 20 years prior to our involvement, but I was putting out a publication. It was called Ponce Magazine, distributed free to students on Oregon campuses. This had a very modest launch, the story about Velikovsky, and Velikovsky himself had agreed to write an article. And then that idea of an article grew into contributions from other scholars that had recently taken interest in Immanuel Velikovsky's work. And we published a special issue on Velikovsky, and it just exploded. It was an international phenomenon. We broke records at a number of college bookstores in the sales of Velikovsky Reconsidered by this little publication, Ponce Magazine. And the result of that was a 10-issue series. And almost immediately after launching that series through like 3 or 4 issues, Doubleday signed a contract with us for publishing excerpts from this series of publications as a book. Velikovsky Reconsidered then became a good seller on college campus bookstores.
Around the same time on the other side of the world, down under, physicist Wal Thornhill was also researching Velikovsky's ideas.
I'm Wallace Thornhill, and my passion in life has been the pursuit of what I call the electric universe. The real inspiration came when I was at high school, and I read Worlds in Collision by Velikovsky. And he showed me there was a way of understanding things much more coherently across multiple disciplines, because what he did was to come to the conclusion that Venus had been a comet within human memory, and that the implications of this were that electrical interactions had occurred between planets and were witnessed by ancient peoples around the world. But the way that they were recorded in myth and legend and so on has been dismissed by modern science simply because they can't make any sense of it. And this is to be expected because the experiences our forgotten ancestors had are completely outside modern experience. As a physics undergraduate at university, I felt that I needed to check to see whether Velikovsky had chosen his sources and that just to fit his argument, which is a very common failure of research. So I used to haunt the shelves of the anthropology section of the university library. I was the only physics students I think I ever saw in those shelves. But just picking books based on their titles to do with creation myths and so on from around the world. And that included, South Sea Islanders, Australian Aboriginal, Dreamtime, myths of Middle India, all of this kind of thing. And I found that I could open those books and read these stories and they sprang to life, viewed through Velikovsky's reconstruction of events. And that, for me, was a good test. Well, while I was at university, I began collecting articles which gave me more ammunition for Velikovsky's views. This was in the mid to late 60s. In the early 70s, the Ponce journal was started up by David Talbott, and I subscribed to those, of course. And there I found a whole lot of scholars who were also inspired and working, trying to understand more about Velikovsky's scenario, which was one of chaos or disorder in the solar system.
I'm C.J. Ransom. I originally was a plasma physicist and worked in aerospace for about 30 years and retired. When I was in graduate school, what's now Dr. David Carlisle and Dr. Jim Durham and I would sit around in the lab sometimes and discuss Velikovsky. When we got out of school, we all agreed that Velikovsky was not given a fair hearing and somebody ought to look at it. So I started doing research. I had a whole bunch of 3x5 cards and I'd write down a reference and this did or did not fit Velikovsky. It supported him or it detracted from his work. After about 6 or 8 months, I had a huge stack of cards that supported him and a very small stack of cards that detracted from it. So I told the other two, and Carlisle was at a meeting in Princeton at a plasma conference, went by and met Velikovsky while he was in town and told him about my research. And so Velikovsky said, well, he'd write me a letter, which he did. and asked me for the information, and so I sent him all of it. And then we started corresponding, and that's how I got into it.
David Talbott was eventually joined in his work by Ev Cochrane.
My name is Ev Cochrane, and I was trained as a geneticist at Iowa State, so my first area of interest was biological evolution. And I've kind of branched out from there into the world of comparative mythology. Oh yeah, I've read every sentence Velikovsky ever wrote. You know, Dave's kind of from the previous generation, and so they were very involved with Velikovsky himself and much more involved in the whole Velikovsky affairs situation. And that's what drew me to the controversy in the field in the first place, was the idea of mainstream science suppressing Velikovsky. I came to it from that standpoint and then just became interested in the science of it. So I've never described myself as a Velikovskyan. I don't necessarily subscribe to his theories at all, but certainly his ideas were the wellspring from where Dave and my work grew, that's for sure. In the early 70s, Dave became enamored of Velikovsky's theory that Saturn used to be a dominant body in the sky. It was known as the primeval sun god. And so that was originally part of Worlds in Collision. Velikovsky pulled it at the last second, intending to come back to a second volume and discuss that situation. He never did. He, after his death, a couple articles were published, but by then Dave had taken the bull by the horns and produced this masterpiece of a book called The Saturn Myth that was, you know, much more detailed and sophisticated than Velikovsky's ever was.
David Talbott was researching all the ancient records he could: hieroglyphs, ancient texts, petroglyphs, stories, to determine what exactly was the experience of the ancient peoples around the world.
I was working with the images of planets in the sky that preceded the explosive birth of the great civilizations. And all of the themes that I found in Velikovsky relating to Venus and Mars, they were all part of that story. They were there. I mean, Venus is a comet, but it had a particular role. There was a planetary configuration in the sky centered on the celestial pole, and this planetary configuration involved Saturn, Mars, and Venus in an extraordinary alignment.
The idea was that it was likely that Earth, Venus, Mars, and Saturn, at least those four, at one point were much closer together and not in orbits around anything, but in a what's called a polar alignment, which is, the joke is, it's planets on a shish kebab. The astronomers, of course, laughed at them. It's ridiculous. You can't have a bunch of planets in a shish kebab. That's nuts. It'll fly apart. You have to have them like an atom. It has to have a nucleus and things around it. That would be stable, but this thing in a line, no way. And there was a fellow by the name of Bob Hubaugh, who's a mathematician, who got to know Dave and said, no, Dave, that's a stable configuration. It's just as stable as the rotating disk.
The value of this idea was, number one, it was derived entirely from things that are not disputed. In other words, the tradition of a primeval sun that is, in the earliest astronomies, identified as Saturn. So if you have a visualization of the ancient sky in front of you, you have this huge sphere of Saturn. Right at the heart of that sphere, you have this discharging comet, Venus, in its very first form. And within that discharging star, as preposterous as it may seem, there is, globally recorded, a darker, smaller central orb. And that is the archetypal warrior hero of world mythology. So what happens to these bodies is the full account of world mythology.
And so that's his life's work. That attracted me to the debate, And so Dave and I started collaborating in the early 80s. I met him in, I think, 1981. And we very shortly thereafter then started writing about the planet Venus together and collaborated on a series of articles. Dave and I first started writing our articles for the journal Chronos, which at that time was the main Velikovsky organ. And that took over for Dave's journal called Pensée, which was from, I think, 1972 to 74. And so once Chronos folded up shop, Dave started up Aeon in 1988. And so it was his brainchild. He organized everything, and so I was kind of his right-hand man. And so originally it was a two-man operation, and we would crank out 6 book-sized volumes a year. So it was a ton of work, and I think we produced some fantastic stuff. And so that came out for about 20 years.
It was inevitable that eventually David Talbott and Wal Thornhill would meet.
Yeah, I met Wal Thornhill in 1996-97 ahead of a conference we were sponsoring in Portland. And I invited him to that conference, and he had come to Portland to spend 30 days in my office, sleeping on the floor with the rain pouring down outside and so on, but for a purpose, not just to come to the conference. It was just a 3-day event. But he wanted to show me that what I had reconstructed is electrical. I'd never even thought of such a thing. So gradually, Wal completely convinced me that we were like this. We were telling the same story, but one was the history of a human experience, and the other was the electrical behavior of the plasma universe that presents that very detail. So it was a wonderful connection.
I've pretty much stayed in the comparative mythology field, but Wal was always interested in Velikovsky's work. I would say he really blossomed in the mid-90s with trying to figure out the nature of comets and how Venus could present the images that we had reconstructed from ancient history. And the upshot of that is you would have to have some pretty powerful plasma-like forces emanating from Venus and associated structures to create these amazingly beautiful and spectacular forms in the sky. So it's really Wal's genius that has fleshed that out. The reason we chose comparative mythology is it's easy to imagine one culture being idiosyncratic and maybe figuratively describing a planet or some historical situation. But by taking the comparative method, if you find the same story in Mesopotamia as you do in Mesoamerica, that is compelling evidence that a real history is behind those common stories.
One of Dave Talbott's fundamental tenets is, don't use a myth to reconstruct the history of humans and the solar system if it's not global. And you will go on to say is, make your history out of archetypes which are globally attested, which are not obvious. Archetypes that combine like 3 different elements you would never dream of putting together, but they are put together all around the planet.
Dave Talbott's story is about cross-cultural myths, taking a look around the world, seeing the uniformity in some storylines, the qualities of these gods, and oh my God, Chinese think the same way about this god, and the Greeks do, and the Mesoamericans do, and oh, this is a human experience. So, this is not baloney. This is some common experience that occurred, and it had to do with something extraterrestrial. We're not talking alien astronauts, we're talking about a experience in the celestial order, a physical experience. But of course they animated it, everything had, its own energy, they wouldn't, it's not a rock to them, it's some god that has some evil intent, or it's warring on another body in the sky, they're exchanging energies. There's destruction happening. There's destruction that can be happening to the Earth. So we tell stories about that. What else would we do, you know, to memorialize those experiences? So it wasn't all a suppression, you know, pushing away of the memory. It was a way to encode it, you know, and myth is the way to encode it.
The majority of our research is just trying to reconstruct the earliest history of Venus in the world's consciousness. Dave is a total expert at the early Egyptian texts. He was always concentrating on the pyramid text, the coffin text, and I was familiar with those as well. Then I moved to Mesopotamian material and discussed the earliest Sumerian and Akkadian writings, and in both cultures you have the leading goddess, Inanna in the Sumerians and Ishtar in the Semitic cultures, identified with the planet Venus, is clearly described as an extraterrestrial warrior that caused disasters on the Earth.
At some point, this polar configuration of planets began to break apart.
The breakup of that system is the story of the departure of the gods. I mean, and in fact, what culture didn't remember? We were once living in the presence of the gods, they went away. Okay, so there's a theme, like all other themes, it has a place in this reconstruction. The gods departed. The soul of the primeval ruler of the sky departs from him. That central soul did not remain in that position. It departed. It became a flaming serpent dragon. It attacked the world. This was the end of the world. And all the stories of the clash of the titans, the wars of the gods, and so on, relate to the dismemberment of this planetary configuration and the incredible activity. What were they battling in the sky with? They always have weapons. Well, we look at the weapon of the gods and we find that it is always the thunderbolt, the cosmic thunderbolt. Not a blast of lightning, a cosmic thunderbolt. It was a thing in the sky. It had visual form. It never looks like lightning. So I gathered up the forms of the ancient thunderbolt. There's lots of mythic images of them, and I showed these forms of the ancient cosmic thunderbolt are the forms of electric discharge in plasma, and this is so specific, it couldn't be accidental. You only have to look to a comparison of electric discharge in the plasma lab to these very elaborately sculpted thunderbolt images from Greece and ancient Near East and so on, and you see, it's a perfect match.
Around 2000, another gentleman joined the movement. His name is Tony Peratt. He was a plasma physicist at Los Alamos Lab. He is, one of the world's top plasma scientists, and so he was even further responsible for showing us how these images could have been created through electromagnetic forces. So that was a huge bolster to our theory.
My name is Donald Scott. I have a PhD degree in electrical engineering, which I used to teach at the University of Massachusetts for 39 years. And Tony Peratt, who was another electrical engineer, he came and said, yeah, that's right. And in fact, some of this stuff, these ancient petroglyphs that we see carved into the rock walls of canyons here, they look just like what I see in my nuclear lab in Los Alamos. And they're called the Peratt instabilities. It's hard to carve stuff on rock with another rock. Try it sometime. I did one time. Tony said, yeah, go out and see if you can carve an X on a rock. You're sitting there and you don't, it takes a lot of effort and a lot of time. So these people were really, obviously, either scared or awed or in religious aura of what they saw in the sky. And so Tony said, yeah, these petroglyphs prove is that these tremendous plasma displays did occur in ancient times, and ancient man saw these figures, which he said, I know, because I see them in my lab, I know they do occur.
It was apparently a somewhat contained environment, progressively unraveling into enough freedom for the planets to find their equilibrium positions in the system we know today. very much unlike and very far removed from that close proximity of this primeval cocoon in which we existed, and the planets were in such close proximity, just dominating the sky. Now it's a remote planetary system, but every culture, I mean literally every culture, remembered the gods departing, and most commonly you see these figures becoming remote stars.
Dave's one of the favorite things he has to say is that all cultures on Earth talked about a time before time. The Garden of Eden, for example. And that's when they were all lined up. They were all inside of a plasma sheath. And the inhabitants had no idea what the stars looked like. They had no idea about the universe because they were surrounded by this beneficent fog, which is the Garden of Eden. And life was easy, but there was no way of telling time. And then finally, for some reason, this thing broke up. It could have been that this little shish kebab was traveling through space and eventually came within closer distance to the sun than it was. And the sun's gravity and electric field essentially disturbed that planetary alignment, and it broke up. So that was every culture in the world. Cultures that have never talked to each other. They have all of them have, at the end of their Garden of Eden, is always the end of the world. And all hell breaks loose. And fire and flame. And, well, you can imagine if you're on a planet that the thing is in a configuration that's breaking up, and then eventually ended up in this very placid arrangement that we have today. So the idea that it was always this way, we don't believe.
And so that's what we've been doing since very early in the 80s, over 25 years, reconstructing that story and that history. And it has, profound ramifications, not only for the origins of religion, the origins of language, but especially for the foundations of modern science, because modern science will tell you Venus has not moved off its present orbit for many billions of years, and we know that to be incorrect. And so if we are right, it really pulls the carpet out from under conventional astronomy.
In fact, if I reflect on the history of paradigm-changing ideas, I cannot identify a paradigm-shifting set of ideas more profound, more fundamental, more sweeping in their implications than the electric universe paradigm. I mean, Darwin had a huge impact on education and scientific investigation. But if you just compare the implications of Darwinian insights to the insights within the electric universe, it's actually no contest, because there's so much more that is being affected by the electric universe that is emerging into human consciousness now. We just go on doing what we are doing, and step by step, it is always bolstering our confidence that a earth-shaking revolution in human thought is coming.
Over time, the community of scientists, scholars, and other experts and researchers in various fields grew around them.
Obviously, I think the Aeon Journal put us front and center as far as organizing a community of like-minded scholars. And so Dave and I were pretty prolific during the 80s and 90s. We were putting out these massive books, and so it would be nice to get some help from other people. And so over the course of time, guys like Wall, Eduardo Cardona, Fred Juneman, and various other scholars and scientists from around the world kind of became interested and chipped in and really helped us out. Certainly Tony Peratt is at the top of that list as far as first-rate scientist that pointed Dave and I in new directions that we wouldn't have been familiar with otherwise, And it turned out to be revolutionary in its implications. And so it's been, we've been very fortunate from that standpoint to be associated with the community of scholars where everybody has complementary and supplementary ideas that can kind of serve as a self-corrective mechanism to keep us on the straight and narrow.
I could name a number of people who have been key to all of this, and one of them was Velikovsky's scientific advisor, Ralph Jurgens. And he published an article in the early 70s which challenged the view of how the sun works. And that was one article where, as I read it, I intuitively knew that he was right, because the model was simple. And it was based on engineering principles, which I understood. I felt I had to take that on board and then see what else could be done with it.
Dave met up with Wall, and Wall began to talk about electrical things and said that this configuration that Gruba says is stable is definitely stable. The electrical properties of these planets would be consistent, and we can go from there. We can have a model and see if it works. Then I got into the act a little bit later, and after I'd read Jurgens' electric sun model, and I was more interested in the sun, still am. There were other people who shared in the similar ideas with Dave. That's Cochrane and Eduardo Cardona, Ginenthal, and a few other people. So the whole group sort of came together. The impetus was Dave and his study of ancient times and ancient stories. That's the way the whole thing got started, and then little by little we've sort of expanded.
This community of scientists and scholars eventually became known as the Electric Universe, or EU for short.
The electric universe acknowledges the fact that all matter is electrical in nature, and that we can understand far more about the universe, cosmology, and ourselves by using this understanding and applying it to a simplification of all of the present physics, which involves multiple forces and multiple particles, a complete zoo of particles, and a lot of confusion, especially with some of the very expensive experiments that have been carried out recently, which have produced just more surprises rather than confirmation of previous ideas. I'm so confident in the interdisciplinary support for the electric universe model. It's not so narrowly focused as modern science is. Most people are so focused on their own area of interest that they don't consider that the problems they're facing may be answered by somebody in a completely different discipline. The communication between disciplines is very poor at present.
The EU has several aspects, a whole bunch of different directions. Dave with his mythology, and Eduardo, God love him, and Wall's and my ideas about electricity and how it all can work. And there's several other aspects of it too.
My name is Andrew Fritz, and my particular interest is in the sociological study of catastrophism. So everybody's different. That's what's exciting about this group, because there's room for everybody. I mean, you got the hardcore scientists, mathematicians, you got the mythologists, you got the psychologists, you got the geology people, you got people wanting to show you the proper understanding of what an atom is.
Irving Wolff, and I became involved in the whole Velikovsky community. In 1974, there was a conference at the University of Lethbridge where Velikovsky was given an honorary doctorate, and I was invited to be one of the group to give a paper, and that's where I finally met Velikovsky, and we were then in touch for the rest of his life. He died, I think, in 1979. Velikovsky vigorously argued that abstract gravity is not the answer to the motions of the heavenly bodies. He believed that electromagnetism played a part, and probably in his mind the greatest part. So he was the one who pushed 70 years ago for electrical interactions in the universe, particularly in the solar system. And Dave Talbott and Wall have picked up from there, and they now say that the entire universe, the whole bloody universe, as big as we know it, is electromagnetic. And this is just starting to come out. What Wall and Dave have started is going to be a torrent of insights into how everything from the smallest parts of the cells in our body to the largest structures in the universe can all be only explained in terms of electricity and magnetism or electromagnetism together. So they're on their way to proposing a whole new paradigm for understanding of reality.
I'm Bill Mullen, and I teach classics at Bard College. I've done that since 1985. So I've been giving papers at conferences inspired by Immanuel Velikovsky, starting from the year in which I worked with him, 1973 to 4. You see the Great Canyon of Mars, a third of the planet. It is a canyon whose features could not possibly have been produced by erosion of wind or water, but who perfectly resemble the kind of configurations that electrical discharges produce, I mean, even in a laboratory. And it takes NASA photography of that Great Canyon, and you look down into the canyon and you see these incredibly sharply etched features all the way to the bottom. That is some mega discharge of some other body close enough to Mars to have produced a huge, as it were, lightning bolt.
The EU, our guys, are of the opinion that there is a heck of a lot more electricity up there in space than most astronomers think. The surface of the sun is very electrical. Thinking about it that way, we've been able to explain some things that regular astronomers, helioastronomers, have no explanation for. We think that stars are born from Birkeland currents. When the Birkeland current gets into a pinch for whatever reason, if you bend it like you bend a soda straw, you will crimp it, and any restriction or crimp, there'll be what's called a Z-pinch, and the plasma reacts and essentially explodes and compresses matter. And that's the way we feel stars and all objects, planets, asteroids, anything you want to think of, are made because of the compression of matter at a Z-pinch in one of these long current streams. The reason that I got into the electric universe was because of my background in electrical engineering. And when I heard astronomers say things that I knew were wrong, I am a reasonably expert, I think, after teaching it for 39 years in Maxwell's equations and a few of the other electromagnetic properties of matter. Astronomers were saying things like, there's an open-ended magnetic field here. An open-ended magnetic field. That's nonsense. There is no such thing. And they talk about magnetic fields that begin with a footprint on the surface of the sun and then they go to infinity. It's impossible. They may go a long way, but it's not infinity because electromagnetic fields have to come back and join. They're continuous closed loops, just like a circuit would be a continuous closed loop. Astronomers have some very wrong ideas about, well, you can't have charge separation in space. Yes, you can. You can't have an electric field that would push on something and make it to move in space. Yes, you can. So I kind of get into this by sort of like running out onto the field like a referee in a soccer match going, time, cut, that's a penalty, you can't do that. And so astronomers have been saying for a long time, plasma cannot support an electric field. Because plasma is a perfect conductor and it will short out like you put a dead short across the battery. It's going to melt everything and nothing's going to work. They're wrong.
My name is Peter Modell. As I understand it, our whole foundation of the thrust of science is material, is materialistic. It's based on the research of physics, physical things. And more the idea came in that physics can answer everything, to the point where what isn't physics isn't real. Yeah? It went in that direction. the whole viewpoint, and this is implicitly behind it, where actually science can answer anything, and what they're not answering doesn't exist. Yes? In other words, non-material existence and so forth doesn't have a place. Now, gravity is actually associated in general understanding with matter. The amount of matter is supposed to be the amount of gravity. And so, by having a universe that's based on gravity, you're actually supporting the whole idea, the whole material idea that lies behind this physical approach. When you shift to electricity, this whole thing drops out. And so the difficulty that many have in letting go the fact that gravity is a negligible force in the universe compared to electricity is because gravity is still tied in with matter. And if you have electricity, well, it's not matter. So there's a whole other range of understanding that has to move in and that has to let go this materialistic basis.
Gerald Pollack, and I'm a professor at the University of Washington in Seattle. I've been, for the past couple of decades or so, I've been studying water. The electric universe people are generally of the belief system that electrical forces dominate nature, the solar system, and the galaxies and such. The feature of weather that we have brought forth is that weather is primarily electrical. And it's not a surprise because you see thunderstorms, electrical storms all the time. And for many people, the presumption is that the electricity is something added on or something exotic, but it's not. The clouds are all electrical. The rain, it turns out, may be drawn to the earth by electrical forces. Most of us think you have a cloud up there and the cloud somehow magically, for some reason, unzips and all the water comes out and falls down. But experiments have shown that it's not true. The droplet is not just falling from the cloud, something is pulling the droplet down. And from our studies, we deduce that these are electrical forces because these droplets are all charged. And most people never even think about this. How come this heavy water is sitting above our heads and it doesn't fall, except when it rains? And so this is a kind of funny question that I always like to ask. And we think we know the answer, and the answer has to do with charge, just like the electric universe people are realizing. The cloud is negatively charged, and it turns out that the Earth is negatively charged as well. If you have a negatively charged Earth and a negatively charged cloud, repel each other. And if they repel each other, then the cloud is going to be high up. And the clouds that have more negative charge are going to be higher. And the clouds with less negative charge are going to be lower. When you listen to your local meteorologist talking about the weather forecast, you'll hear about temperature and you'll hear about pressure. Not once have I ever heard about charge. And I think answering the question, shall I take my umbrella to work today? You know, we don't know because often there's a 50% probability of rain. But I think that the predictions will get a whole lot better if people begin to understand that electrical phenomena dominate all weather.
Of course, to be able to really grasp and propose such revolutionary ideas, it is necessary to abandon some outdated but deeply held beliefs about the nature of the universe and its history.
It was about almost 40 years later when I suddenly realized that to get any further I had to discard Einstein's way of looking at things. It was a necessary step. I had to take that step to take the ones that were just to come, just down a few years later. And I had to dump Einstein and go back to the classical way of doing science. I was working in London at the time, and there was a scientist who actually wrote the entry in the Encyclopedia Britannica for some years on special relativity, until he realized that he didn't understand what he was saying. And he developed a very simple argument which ended up in the Times. It was a famous argument in the London Times. It was never resolved. So he decided, since he never got a proper answer to a very simple question, to write a book called Science at the Crossroads. With that reinforcement, I was prepared for anyone who attacked me on the basis that, Einstein is a hallowed gentleman and that no one can question him because everything that's ever been done confirms his work. And that's so simply because he removed the standards of measurement of time and distance. So once you've done that, and you can choose any arbitrary observer in the universe to match, to give you the results you want, sure, The fact is that doesn't actually prove anything because his work is fundamentally, physically meaningless. There are all sorts of other aspects to this, but one of the main things about the electric universe is that it re-establishes the standards of measurement. And that is, and this is something that Newton recognised and some of the great philosophers of the past, the standard is the fixed stars, the rest of the universe. So it's motion with respect to the rest of the universe that determines the energy and the actual speed of an object.
If you look at Einstein's own work on general relativity, he has a couple of pages describing the assumptions or the principles that he uses. And then there's pages of mathematical equations. Now, most physicists would be trained to look at his math and then to train to look at the field equations and to kind of gloss over the assumptions part. But all of those assumptions are themselves up for debate or questionable. They're ways of framing the problem.
However, physicists are not trained to question the assumptions.
Well, this is the problem, the way it's taught. You imagine you go into school and everyone is chanting hymns to Einstein. You're going to be excommunicated, tossed out. You'll never have an academic career. It's quite a challenge because each era seems to work with its own mythology, and that sets the ground rules for what you believe and what you don't believe, and science is just another mythology. It's funny because science, of course, is supposed to have separated from religion. It never did. It even took the creation myth with it and added maths to it to suit whatever they wanted to dream up. And so we've ended up with a scientism. It's really nothing to do with real science.
Part of the problem is that the scientists have taught what was taught in 1950 since 1950 and before.
An example of someone who was thrown out of school for challenging Einstein's ideas is Stephen Crothers, who was a physics PhD candidate at the University of New South Wales.
I've done work on special theory of relativity, general relativity, and its related mathematical apparatus, thermal emission, that's including, of course, Kirchhoff's law and Planck's equation, which I've done with Professor Robitaille, who's been working on this for years and is essentially the prime mover on this. So we've written one paper together on that, and I also do a bit of work on electrodynamics.
Kirchhoff's law of thermal emission is a pillar of modern physics. Assuming its validity, Max Planck went on to formulate his famous equation, which proposed that electromagnetic energy could be emitted only in quantized form. Quantum physics was then born.
Black holes, big bangs, these things don't exist. It's all a fantasy. The cosmic microwave background is essential to the Big Bang cosmology, but we know that they can't possibly exist because, first and foremost, all of this rests on the validity of Kirchhoff's law and the University of Planck's equation. But as Professor Robitaille has done recently with a very simple experiment proving that Kirchhoff's law is false. So this is a very simple experiment that anybody can do in their kitchen. I mean, literally in your kitchen, with a small amount of outlay for equipment, maybe $1,000. You don't need a $100 million satellite, or hundreds of millions, or $750 million satellite, like many of these, or these various satellites have cost. And of course, these projects, who can reproduce these so-called experiments? You have a one-off, more or less, or you have a small coterie of people who have controlled these projects, and they make ancillary projects to the project that they've done to confirm their own claims. Well, there's no independent inquiry here or no independent confirmation, so it's not science.
I think there is a problem with peer-reviewed things, especially when the peer reviewers have an interest in the accepted theory. So they're going to be very careful about letting you publish anything that's contrary to their accepted theory.
Peer review doesn't work. It only works to protect the status quo, the settled science. Confirmatory bias is one of the big problems in science. In other words, forget your failures. In fact, half the time you don't even publish them. This is one of the other difficulties. So we have this skewed view of where science is really up to. And people who have relied on an expert in one field to give an answer which they can rely on is often misleading people in another discipline. And so you get these knock-on effects, and the results are that science at present is a real shambles. The real scientists are the ones, usually the first ones to admit it. The ones who are just there for the show will say anything to maintain their position. Oh, the quantum business, well, that's not science either. Physics died at the Solvay conference, you know, the one where Einstein and Bohr and all of those other big names of science were assembled. We had Einstein in the front row, all seated, of course. This is settled science, so they're all seated. He was the one who destroyed physics by removing the standards of length and time. And in the second row, second from the end, was Niels Bohr, who removed cause and effect from quantum mechanics, which meant that that was no longer physics. So we've limped along since that early part of the 20th century, not doing physics. The problem is we see all of these things that are put as facts and conclusions which are not facts, and they are unsupportable.
Big Bang is based on the general theory of relativity, and Einstein's general theory of relativity is riddled with contradictions, impossible physics, so-called physics. It's a bit of an oxymoron to say physics, but impossible physics and invalid mathematics. There are two things that a physical theory must satisfy. It must be logically consistent and it must be in accord with reality or experiment. Well, if it fails on either one, then it doesn't hold. And in the case of Einstein, certainly on the question of logic and self-consistency itself, it's false. So that doesn't hold. The second thing is it's been experimentally proved to be false because, as I said about Kirchhoff's law, without that law, the whole of Big Bang cosmology is untenable. Well, Kirchhoff's law is false. That's it. So we know for sure that this Big Bang mysticism, it's not science, and it's a fantasy.
Well, the Big Bang is nonsense. It's been called the ultimate free lunch, because you start with nothing and you end up with everything. It's only there because of a misinterpretation of redshift. And there's a lot of ironies in science too, because no one bothers to check the history or the documentation. You accept what you're taught, because in university it's a hothouse. You've got to get through and do what you're told to do in order to get your degree. You don't have time to go back and look at the controversies and the thoughts and the context at the time. Edwin Hubble thought that the expansion of the universe was the least likely answer, and he was right. Right to his deathbed, he thought that the Big Bang scenario was the wrong one. But of course, he's now up there, another icon, and history's been rewritten by the winners. And unless you go back and do your own checking, you would never know it. And it's the same with most of the so-called big steps forward in science. The politics of science are such that Nobel Prizes are misattributed to people who didn't invent something or didn't discover something but later developed it. And because this person who discovered it wasn't a card-carrying member of the fraternity, so to speak, gets discarded, and the person who develops it gets all the prizes. And this has happened repeatedly.
The singularity of a black hole is supposedly composed of a finite mass which has zero volume, infinite density, and infinite space-time curvature. Well, in general relativity, there are no forces of gravity. There are forces, but gravity is not one of them because it's space-time curvature. Well, infinite space-time curvature, therefore, equates to infinite gravity. But there is no such thing as a finite mass of zero volume, infinite density, and infinite gravity. There's no such thing exists. This is a fairy tale.
It's like in mathematics in high school, you know, we have the equation for Young's modulus and the stretching of a spring. It's like applying that formula endlessly until the spring's long broken, but you're still using the formula. This is what has happened. And the introduction of infinity into physics and the renormalization that they use, I mean, that's nonsense. If you hit infinity, you're no longer dealing with numbers and your mathematics is no longer mathematics. I mean, it's a waste of time.
Is science still focusing on theories that have long ago lost touch with the physical realities they were made to explain? Biologist and science historian Rupert Sheldrake spoke at an Electric Universe conference, outlining the 10 dogmas of institutional science that are still taboo to question, even though they can be easily disproved with the existing evidence.
There's a conflict in the heart of science between science as a method of inquiry about the testing of hypotheses, looking at the evidence, finding out what's really going on, open-minded, subject to correction, and so forth. The ideal of science, which many people think of as what science is. It's what science ought to be, and I agree with that ideal. The reality, as many of us have encountered through bitter experience, is rather different. For many people, science has become a belief system, a worldview. This is sometimes called scientism, where people take the dogmas of science to be a kind of religious belief system or quasi-religious belief system. And it's this dogmatic belief system which I think is now constricting and holding science back in a very serious way. In almost every branch of science we see the law of diminishing returns. More expensive research yields fewer and fewer really new results. And I think the reason for all that is this dogmatic belief system. If science can be set free from it, new experiments and new possibilities open up in every area. What I do in my book, Science Set Free, is take the 10 dogmas of institutional science, which are part of the scientific worldview, and turn these dogmas into questions, treat them not as beliefs or truths, but as hypotheses that can be tested against the evidence. I then look at them scientifically to see how well they stack up when you take into account the evidence. None of them do. In every case, new possibilities open up. Science would become regenerated when we undergo this process. Now, within science itself, of course, people at the leading edge of research in many ways have moved beyond this belief system. Research scientists are not necessarily committed to this in every detail, but they're usually only at the frontier of one region. A physicist might be at the frontiers of cosmology and have gone beyond some of these dogmas of physics, but they wouldn't question the dogmas of psychology or biology. Those would remain more or less intact. So there are various people who question bits of it, but there's very little that's been done to question the whole thing. This is essentially the materialist worldview. And it became the dominant view of science in the 19th century. Science was, as it were, hijacked by materialist philosophy, and since then has been a wholly owned subsidiary of materialism. There's no reason why science has to be materialist. It wasn't materialist before the 19th century. And I think we can go beyond that to a new, more inclusive, more organic, organismic paradigm for science. So what if the electrical patterns in the sun are an interface with the sun's mind? What if the sun thinks? Now, as soon as you raise that question, you realize this is an utterly taboo subject. You're not allowed to ask that question. It's matter's unconscious. Since the 17th century, materialists have assumed, and dualists, had assumed that matter's unconscious. It's simply off limits. However, all traditional cultures have treated the sun as alive, and indeed the planets and the stars. Children, when they draw the sun, draw it with a smiley face. So this in itself is taken as evidence against the fact that the sun can be alive or conscious, because if children see it that way, it shows it's a primitive, childish way of looking at things. And the fact that people all over the world show it that way until science comes along, again proves it's primitive and superstitious. We've risen above it. I don't think we've risen above it at all. I think we've sunk below it to a level of dogmatism which simply closes off a whole area of questions for no reason other than the fact that a French philosopher in the 17th century chose to divide up the world in such a way that he defined matter as unconscious.
The movement into the Renaissance was the loss of meaning. Then you moved to Bode's law, which gave you a formula for the distances of the planets, and that was good. What you needed were formula, calculations, and so forth, and if it meant nothing, it didn't matter anymore. And after the Renaissance, we moved into a period where things didn't have to mean anything anymore. There was no cosmic vision behind it. They just had to match up and work out. That has many, many more implications than what I'm saying there. But I have the feeling that we reached a crisis in the contemporary period where the lack of meaning is problematical again.
Well, science would improve by going back to a more classical style of teaching, where the scientists in the past had a classical background. They learnt about ancient cultures and so on, as well as investigating electricity and magnetism and astronomy and so on. There was a sense back then that science was all about simplification, that you tried to find a more simple way of looking at things. But it seems that after the two wars in the 20th century that government funding became very important, that the command was to shut up and calculate. There was an awful lot of mathematical work involved, which is rather deductive rather than inductive, and the way of operating back in the classical era was induction. You performed an experiment, you saw strange things happen, and then you tried to think of where you might have seen that kind of pattern of behaviour somewhere else. Now it was a case of if the mathematics didn't agree with the results, then you just fiddled with the mathematics until it did agree. But that didn't teach you anything new.
Something happened in the Renaissance which isn't often fully described. Here you have this free being who's able to make choices. But what actually happened is that man lost his identity at that moment, and there's a whole other way of seeing what actually happened, which has to do with the loss of personal meaning and the loss of personal connection. It's terribly sad that young people who have this impulse where things are meaningful and this starry sky is amazing and you want to discover more, and it's all turned into this abstract language which doesn't make sense anymore. And it's happening in almost all professions and all areas. How many wonderful young people have I known that went into the medical profession because they wanted to help people, nursing or other. And they got into a hospital situation and they're the dispensary of medications or of operations or something, and the caring that was the initial impulse doesn't find its place anymore. And we can say this of so many areas of learning which lead us out of the reason that we went into them. instead of developing and becoming something even more intense. And that's something that's very true of our whole epoch. And it shows that something's amiss, something's dreadfully amiss.
It's one of the legacies of the split between philosophy and science in the 20th century. It's a strand of thought that's sometimes called logical empiricism or positivism, which really greatly influenced science into this rise of the professional school of science, is to believe that science has to be free of metaphysics, and that it's the ideal is to have a science that's pure without having to make any such grounding claims or any such framing devices. So in my view, this is a delusion. And it would be much better if we could speak openly about what the guiding assumptions or the premises for a theory are, and speaking about them openly instead of trying to hide them away.
Well, despite Einstein's speed limit on the transfer of information, we know for sure that that's untrue and that the universe is full. It's full of an ether. You must have a substrate for the universe from which the visible things that we see, the planets, the stars and everything, must be constructed. You cannot create matter from nothing. You know, there is no miraculous creation story for the electric universe. The big mysteries remain, but at least we can now begin to ask the right questions. But the essential thing is this connectedness, and it's a connectedness at all levels, and it helps you understand the difference between living creatures, how we are formed, how we're connected with everything around us, the environment and so on, and how we're also connected to a kind of consciousness of the universe.
And there's reason to find either an organic sense or an integral sense or some way of finding personal meaning and global meaning in what we're researching. And I think the electric universe does open that possibility, where things are connected, stars are connected, galaxies are connected. Time is not a question, there's timelessness across the universe, where we're in communication, and also the perceiver and what's perceived comes into a whole new relationship. And we're moving back into an area where meaning is meaningful, something that was lost for many hundreds of years.
It's all one. We're a manifestation of something beyond ourselves. That's my view, having come to this far down that path. To get to where I am, you have to be prepared to stare into the abyss and still take the jump. And I've done that repeatedly, so that jump is one that's not so difficult. It's also very empowering because you don't get so attached to meaningless things, the meaningless things in life. The real meaning is your experience here, because we are the self-referential part of the universe. The universe learns through us. We manifest in order to understand and to allow that understanding to permeate the universe.
If the electric universe model can really help explain the universe more completely and accurately than our current understanding does, why is institutional science so reluctant to consider it?
So prior to the proposal of the existence of electrical particles, you might say, of the electron, protons, and that, people didn't study things that hadn't been invented yet. So there was no electrical engineering. There was no real electrical physics. Electricity was unknown prior to, let's say, the turn of the century, 1900. And so they never studied it. And astronomers, they're trying to tell you, us, what happened far, far away and long, long ago. Well, as we all know, that's the way any fairy tale begins. So they can pretty much say anything they want to, because there's no way in their particular science to test anything. Well, it's a question whether or not untestable hypotheses are science at all. And because they never had electricity, they explained everything that they possibly could by any other means. Thermodynamics, fluid dynamics, now there's magneto-hydrodynamics. because they thought they could get away with ignoring electrical processes and came up with a bunch of hypothetical answers for how things work, that when other people came along and suggested that these causations, these mechanisms that they wanted to explain, were really better explained by electrical phenomena, they rejected it because they never had studied it. I mean, in my 39 years of teaching, I don't think I had any graduate students from the physics department at all.
Right now we have cosmologists, or scientists more generally speaking, are setting all the terms for how to approach and understand the universe, and they're also the ones who judge whether they think a theory has more merit or not. To some degree, the core of the model is taken as a matter of faith, and that if you are to question it, then you risk running afoul of a lot of things regarding, funding and career and so on. On the one hand, especially if you are a scientist. You can build a career now on challenging some of the upper blocks, so to speak. For example, dark matter, there is a real challenger to this particular part. I find very few scientists are willing to look at the more questionable assumptions underneath the core building blocks of how we got here in the first place. It is much more convenient to add things to the model and preserve the existing structure than it is to radically rethink it.
And now scientists are coming out of the closet, so to speak, and letting us know that we're in serious trouble. But of course, the media aren't interested. All they want is the success stories from science, and that's all the scientific hierarchy want, because they rely on government funding and confidence in what they have to say, or what the experts have to say. The funny thing is, this is just a local anecdote about Australia, we have a government which promised innovation, and of course they asked the universities to head up this innovation, but they're the last people to ask, because real innovation comes from individuals. But the problem is, how do you find them, and how do you get the funds to them? And of course the universities would do everything in their power to stop it if they did. They get away with this kind of activity because they have their own media departments now, the universities, and there is no investigative journalism being done like it is in the finance industries and in politics. It seriously needs outside scrutiny because they do what they like. They're practically unaccountable to anyone. Being the experts, they're always called in to pontificate on who's right and who's wrong, but they're the last people in some ways to do that. So this is a real problem. If we want to get to the science of the future, it's going to take a revolution.
Because of the vast sums of public money that are involved in projects, we're talking hundreds of millions to billions of dollars. And so whenever this kind of money is involved, you can rest assured that there's corruption. The other thing, of course, is that the scientists are supported on many of these fantasies by vested interest of business and contractors, for instance. Just like in defence, they want to get contracts to be able to build these contraptions. Well, there's hundreds of millions or billions of dollars of public money that's pretty well unaccountable, and so it doesn't matter if the machine doesn't work or if the scientists are living in fantasy land, as long as we get the contract. So we'll have lobbyists with government, and we'll support the scientists and tell everybody that we're looking for aliens or whatever it might be. We'll turn it into science, and that way this money can be made.
I think the expression that is used very often is groupthink. A group of people who champion the existing idea, they feel comfortable supporting one another. It's sort of like a family. They like to support the well-being of one another. And when an intruder comes and says, well, your family has a few problems here, they stick together. You might call it a mafia group. Some people have called it a scientific mafia. They get together. They have a lot of power and a lot of strength, and when the intruder comes with a disruptive idea, it's very uncomfortable for these people.
They have to basically admit that they can't explain all of it, that they've had it completely wrong. but Velikovsky's got to be wrong. That's part of the problem, because they vilified Velikovsky so much that now you can't admit that a lot of these things are correct. Because Velikovsky said that. We can't be associated with anything like that.
There is a major paradigm that controls all of science at a given time, and that everybody within it works within that paradigm, and what they usually do is the newcomer proposes the paradigm, and then everybody else simply does experiments to refine and expand it, and they never question it, and they simply make it more complete. But when discordant, anomalous data appears, and when it continues to appear in great numbers, so that the old paradigm cannot accommodate and explain all of these, then there is a period of turmoil, out of which comes a new paradigm which can explain all of the data more inclusively than the old one did. And that's how revolutions happen in the history of science.
It's more of a matter of a whole bunch of little problems. With the funding, you want to get a degree, you want to get a job, you want to get a contract. All of those things are impediments to thinking outside the box. And in fact, in the book that I wrote, I referenced someone who says that the National Science Foundation will not get off the beaten path until they've completely beaten the path. They just won't fund any odd type stuff, although it may turn out to be groundbreaking or earth-shaking or something.
I mean, obviously they would much prefer that it came from within their own ivory tower. So, I mean, obviously we're viewed as outsiders, and in some sense rightfully so. We're not astronomers. The prevailing paradigm doesn't really listen to naysayers from the outside, and so, you know, you've seen that from the time of Galileo on. The revolution doesn't come easy to the physical sciences. And so Arthur Koestler, in his discussion of the history of astronomy called The Sleepwalkers, he had a fascinating quote where he said, you know, it's not the ignorant people in the backwoods that are unamenable to revolutionary ideas, it's the guys in the ivory tower up there, the astronomers themselves, that are pretty stubborn about taking on new ideas.
Well, it isn't hard to grasp new concepts when they come through. They're easy. What's hard to do is surrender the old concepts. It has to do with human nature is really what it is, because scientists have another occupation, you might say. They happen to be people. And when you have a person, you have belief systems, you have a sense of your own security and your own standing, right?
Science is no different to any other human endeavour. All the base elements that are present in other aspects of society are present in science. The idea that science is an altruistic type of self-sacrifice to look for the truth is just a fantasy. It's not true at all, although you've told that at school when you're young. Just like politicians will tell you things when you're young and you believe them, right? Well, science is no different.
We are still in the phase now where the old way of life is resisting. It has dug in its heels and it doesn't want to let go because they have a lot to lose. All their money, all their power, everything else, you know, all their status. Even the scientists don't want to say electromagnetism is right, because then they'll have to give up their jobs and bring out other people to teach physics at Harvard and so on. So there is tremendous reluctance and resistance, but they ain't going to stop it. This is the wave of the future.
So we're talking about human nature, and it hasn't changed. Everybody knows the Galileo story, but it goes on from Galileo to this very day. In fact, there are very few scientists, I know quite a few in different fields, who have actually succeeded in gaining acclamation, recognition for their ideas that run against the mainstream. Some ideas are perhaps bizarre ideas that don't really have any chance of, they're crackpot ideas, but others are not, and there are many of them around, many thoughtful, intelligent people who have new ideas that fit so naturally with the evidence. They run into obstacles, and they're not scientific obstacles, they're obstacles that have to do with people.
We are today in the midst of a revolution. How long it will take for the war to end, I think the outcome will be in our favor. Certainly, the old way, no matter how much it resists, no matter how much they control the centers of power, they control the universities, they control all the large experiments, they control all the departments of physics, they control who's going to spend $20 billion on another CERN accelerator and so on. We won't give it to you, we'll build another one of our own and we'll tell the whole world that we found the Higgs boson. Well, they haven't found it, but they have to show that they've done something, which means give us more money to build another accelerator, an even bigger one, and so on. So it's big business, it's power, it's status, it's entrenched unwillingness to change ideas, but we really are at a pivotal moment if you look back on it. And if I could live another 100 years, I would look back upon this period and say, that's when the change started. And it kept increasing until finally more people came around to that point of view. And the old power center, which are still very strong today, would be seen as dinosaurs. And the dinosaurs would die out. And that's the way I see the electric universe now.
The money that's being wasted. It's funny in some ways that the electric universe work has been helped enormously by NASA's space shots and so on, but only by accident. The very fact that they visited all of the planets in the solar system has helped us enormously because we've been able to predict in advance what would be found and been correct when everyone else has been wrong in the scientific community. And we've done that repeatedly. I was the only one on planet Earth who's predicted what they would find when the Huygens lander sank through the clouds of Titan. I was the only one on planet Earth that predicted the flash on that comet in the Deep Impact mission. And I did it when they announced the mission, before they even got there, 4 years before. So I'm quite happy to make these predictions because I'm so confident. And I think if your mind is open and it's prepared to accept ideas like this, that is easier. It's much easier than if you try and come from a traditional trained background and then try and take that leap into the dark. This way you're not so concerned by the dark.
In conclusion, the Electric Universe Group provides a model, not just for a new cosmology of the universe, but also a model for a community seeking to break through the shackles of a prevailing paradigm in order to transform stagnation into forward progress. Perhaps the cooperation and collaboration of a diverse community of like-minded individuals dedicated to the task is the only way to bring forth the necessary revolution, which humanity needs now more than ever.
We are talking to people who have, by random courses, seemingly accidental courses and so on, come together in a sense of incredible inspiration and unity. I mean, everyone in our group recognizes that there is a wall that is almost impossible to penetrate. But we see these little symbols and signs of breaks in that wall, cracks occurring in that wall. And conventional science has been moving toward the electric universe. It is coming into the electric universe one little step at a time. Now, will we accelerate that at some point? I think most intellectual revolutions go like this, so where is that juncture at which it just soars into human consciousness within the sciences?
In our case, it's pretty certain that modern astronomy, modern cosmology is just going to go right in the garbage can. And so you're going to have to become acquainted with the idea that the solar system is of relatively recent date, the order of the solar system, and that it is subject to radical change. So that's a shocking idea, kind of like Copernicus showing that, whoops, the sun doesn't really go around the Earth as we always thought, but the Earth actually moves. So those are revolutionary ideas.
Yes, it's incredibly beautiful because it consists of recognizing patterns at all scales in the universe, from the subatomic to the supergalactic, larger than galactic clusters even. And in this new paradigm, mathematics is not going to be the principal method of proof. Visual intuition is. You see those patterns there at every scale, you know something is going on. That's what I feel about the universe that the electric universe paradigm shows us.
And I think I feel that way when I talk to people about the subject, that I feel like if you take it deeper, if you understand what's happened, you know, it's really a catharsis and a type of healing, sort of the messianic bits of people involved with the electric universe, that we all think in some way that, you know, our contribution is going to go a lot towards helping people feel better, that they've discovered something that's really important that's been hidden.
Electricity is important. Don't ignore it. We can explain things by using electrical laws like Maxwell's equations and Lorentz equations and stuff like that. That seems inexplicable if you confine yourself to Newtonian physics.
I think that the electric universe community are contributing positively in the sense that there are opportunities for people to speak of these ideas, to be able to question what's the dogmatic mainstream ideas, which we know are wrong. This in itself is a positive thing. Whether they have the answers or not is another issue, and I would advise anybody to approach electric universe or any other ideas or scientific endeavour with the same objectivity, because if it's a mistake, it also needs to be corrected, and everybody needs to be able to correct errors along the way. It's part of science. It's silly to be dogmatic about some scientific doctrine, because it's not science if it's a doctrine. You know? But I see positive things in the EU in this regard. But I don't say that they've got all the answers. I don't think anybody has the answers. It's not part of science. So we have to be vigilant that we as other thinkers don't fall into the same pattern as what science has now been in for the last 100 or more years, where it's disintegrated into intellectual decrepitude.
Scientific revolutions have been few and far between. If you think about it, there have been lots of technological revolutions, right? iPhones, laptop computers, what have you. But if I were to ask you if you could name a scientific revolution that's occurred in your lifetime that has succeeded in changing the world in the same way that structure of DNA that was more than 60 years ago, or the splitting of the atom more than 70 years ago, they changed everything, right? Everybody's concept, everybody's world. And can you name something that's happened in the past 30 years that's equivalent to that? And it's really strange because so much money is going into science. With so much money and lots of progress, the progress is incremental. See, it's not revolutionary. Lots of progress, but not many scientific revolutions. We face a lot of problems these days that need solutions, and often solutions will come from scientific revolutions. The revolutions will breed technologies, and the technologies will solve problems. And perhaps we can solve some of the terrible problems that we face in our world today.
I think scientists have begun to look more broadly. I think the evidence for all kinds of taboo subjects, it's just increasing over time, and there comes a point as how much do you have to have before you take it seriously. And I know a number of scientists who have been doing great work looking at ESP, remote viewing, all this kind of thing. And the beauty of it is that I can see how it works from an electric universe point of view. Everyone else considers it spooky and nonsense, but I can see how it works. Or at least the fundamentals, which allows researchers to begin to ask the questions that may allow what the scientists would be satisfied with, real data or ways of detecting these things in such a way that they can be confident. I mean, they like repeatable experiments. Now, in an electric universe, that may not always be possible because you realise that in a connected universe, the electric universe, the observer, the experimenter is part of the experiment, whether they like it or not. I mean, this has been found a number of times where the thoughts of somebody can affect the outcome of the experiment. Well, it's all connected.